Hi everyone and welcome to my video on finding side lengths for trigonometry. Yes, very exciting. My name is Darren from MaffsGuru. Yes, there it is, M-A-F-F-S Guru. Not easy to spell, but wow, is it easy when you find the videos. I just made that up. Bad, isn't it? Yes. If you can head over there, you can get the downloadable notes, the stuff I'm going to write all over, exam questions, all these videos in this series, and so much more. Before I get going, do me a favour, subscribe to my YouTube channel if you can. It doesn't mean very much to you, but at the end of the day, when I get those 3 extra subscribers, I go nuts. Seriously, sitting in a room talking to myself, you know, I probably could make ASMR videos and make a lot more subscribers, but it's not about that. I want to be able to help people do maths. So if you can subscribe, awesome. If you can tell your mates as well, that'd be greatly, greatly appreciated. And your teachers that this resource is there, again, that would be massive. Right, learning objectives. We're going to really build on what I did previously, and we're now going to be able to use trig ratios to help you find missing side lengths of right angle triangles and be able to use trig on your calculator. Okay, so that's going to become really, really important. You're going to need a calculator with you if you want to play along, which sounds a bit weird, really. But anyway, should we get started? I should think so. Now, in my previous video, we looked at the fact that the most critical part of all of trigonometry isn't just knowing what SOHCAHTOA is, right? That word, to be able to split it up into the trig ratios, but it's to be able to label a right angle triangle correctly. And again, if we remember, our right angle there always points to my hypotenuse. The angle is like an eye that always looks at my opposite. And again, the one that's left is the adjacent, or the one that's stuck to the angle is the adjacent one. And once we've got that, we can use our diagram and our labeling along with SOHCAHTOA to basically help us find missing angles, missing side lengths, and so much more. Nothing more. I actually just made that up. Let's just recap Pythagoras' theorem as well. Again, these videos are all on MaffsGuru.com. If you are able to head over there and sign up, that would be great. Basically, c squared equals a squared plus b squared. When we are given a right angle triangle with an angle inside, most times it's going to relate to trigonometry, the stuff we're actually learning now. Let's put the right angle there. But lots of times we will give you 2 side lengths, maybe one there and maybe one there, and expect that you're going to be able to find this missing side length as well. In fact, for trigonometry, for trig ratios, you're going to have to find that one out as well. So you've got to be pretty good at Pythagoras theorem to be able to help you do that. Now again, a lot of this I start to do in my head because I go, well, that's 1 squared. That's 1 squared. So when I'm doing Pythagoras theorem in my head, if you remember, it's c squared equals a squared plus b squared. I know that that's my A and that's my B and that's my C. So I always square this. So 1 squared is 1. 1 squared is 1. Add those together, that gives me 2. And then I happen to know that this will always be the square root of that number. So I know automatically now that becomes root 2. These are all shortcuts to make life a little bit easier. If I do another example, for example, let's have 2 and 3 there. All right, and I call that C. Well, what do I know? Well, I know if I square that value and add it to the square of that value, it's going to give me c squared. So I go 2 squared is 4, 3 squared is 9, add those together, that gives me 13. And so this value here would be the square root of 13 as a surd. And surds are going to be massively important in all this. Don't just keep using your calculator and turning it into decimals, because having a ratio of 1 over, oh, I don't know, 4.2713 doesn't make any sense, because we cannot in maths mix fractions and decimals together, right? So that's why we use surds. Becomes really, really important. Right, so that's Pythag recapped. And again, surds here, again, is really, really important. Now, I'm going to bring up my calculator. If you are using a TI Nspire or Casio ClassPad, you've got to make sure it's in the right mode. Now, generally speaking, these calculators come with radians as its default. If you have your calculator in radians, you need to change that post-haste. Lots of ways of doing it for the ClassPad and what have you. TI Nspire likewise. You can either click on that top corner and you'll notice it will cycle between deg and rad. You want it in deg, D-E-G. Alternatively, you can click up here on dock, go 7, settings and settings, 2, which is document settings, and change angle into degrees. You'll notice there's always a third one called gradients, but I've never used that. I think that's for uni. So you've got to make sure your calculator is in degrees. If not, you're going to get some really horrible things. Do we want surds? Well, what I might do is change my calculator again into surds, which basically changes my calculator mode into exact, because I can always convert them back later. So that's going to be really, really important. But again, just to highlight or just a shortcut, a surd is a number that can be written as under a square root sign. Things like those are surds. I wouldn't write root 9. Why? Because the square root of 9 is actually 3. So that one we tend to use a lot to try and trick you. So don't get tricked, okay? Okay. Right, using a calculator to find a trig ratio. This is massive, and a lot of people don't really understand what's going on here. So I'm going to go back to a little bit of SOHCAHTOA. So there's SO, CA, TOA. If you remember, these three letters are just shortcuts for some trig ratios. So let's use SO first. So we know SO is a way of writing that sine theta, or sine of the angle, is equal to the opposite divided by the hypotenuse. Now this here is a fraction, right? A fraction. We normally can work that out in terms of side length. So if I was to have my if I was to have this as my theta, and I was to have this as 1, and that one there is 2, then basically that's sine. Why is it sine? Because here is my angle, it's looking at my opposite, and I've been given my hypotenuse. So in this situation here, we would know that the sine of theta is a half. Now, your calculator has all of the angles in its brain. It can actually work out these trig ratios really, really simply. And what I'm going to do is bring up my TI Nspire now. I'm going to actually close this down. Let's clear that down. No, I don't want to save it. I'm going to open a new calculator, check that I'm in degrees. I am. Now, if I go trig, because maths is triggy, lol, and I go sine of 30 and hit enter, what do you notice? It's equal to a half. So the sine, he says writing in highlighter again, sine of 30 is also a half. Your calculator knows that the sine of 30 equals a half. But what does the 30 mean? Where does that 30 come from? Well, if we now compare our formulas, that number there matches the 1, that 2 matches that 2 there, the sine matches the sine. Hold on a moment. Theta. So what this is saying is that a triangle with a side of 1 there and a side of 2 there will actually have an angle of 30 degrees. What? So what would happen for 31 degrees? Well, it would be different. 31 degrees would not be a half. If I bring up my TI Nspire and I go trig sine 31 and hit enter, well, you're going to say it's just written that down. Yes, because your calculator can't write it as a fraction. So there we go. When I work out the sine of 31, my ratio is 0.52, not 0.5. Remember, that's 0.5. So an angle of 31 degrees will not have side lengths of 1 and 2. They'll have different side lengths. And your calculator is amazing at remembering all of this stuff. It knows what ratio of sides would be given by each of the angles. So let's have a look at this one. Cos of 60 degrees is equal to a half. So if I now draw a triangle, and I've got this one here as theta, yes, then what it is telling me is that if this angle here is 60 degrees, then we now know that because cos, let's see, so cos theta is equal to the adjacent over the hypotenuse. The calculator is telling me that my ratio of a half, my ratio of my side lengths, my adjacent over my hypotenuse is equal to a half. So my adjacent is going to be 1 unit and my hypotenuse is going to be 2 units, right? So there we go. I can now use this to help me find various side lengths. I can draw my triangle again. What about the tan of 45? Well, the tan of 45 is equal to 1. So here is my right angle triangle. let's say that that angle there is 45 degrees. So tan is the opposite divided by the adjacent. Well, we've been told that that's equal to 1, which as a fraction is 1 on 1. And so we've got that my opposite is 1. My adjacent is 1, and there we go. I've got my triangle. What? This is amazing. What about the sine of 60 degrees? So here we go. Oh, he says trying to draw the triangle and fluffing it completely. So let's now say that that angle there is 60 degrees. We know that sine is opposite over hypotenuse. Oh, okay, so it's now telling me my opposite side is root 3. So that side there is going to be root 3, which is a surd. My hypotenuse is equal to 2. Ka-ching. These are all ways of working these out. Now, unfortunately, not all ratios are very, very nice. Because as I've just said here, if I put into my calculator the sine of 20, I get that as a ratio. Now, again, that is still a fraction. I can still write that as a fraction, although it looks really, really horrible. Which tells me that if this angle here is 20 degrees, my opposite side length is 0.342, and my hypotenuse is equal to 1. All right, so again, not all of these ratios come out nicely, but the fact your calculator can work them out for me is actually really, really helpful. Let's put it into practice. Okay, so using this information, let's find some missing side lengths. Right,